Welcome back again to Advanced Functions, MHF4U1. This is Exponential and Logarithmic Functions chapter. In this lesson number 4, we're going to recognize and connect between the laws of exponents and the laws of logarithm. And using those laws, we're going to simplify different expressions. First, let's go over some of the rules or laws of logarithm. Well, from the previous chapters, we know the product law for exponential. If you were to have a same base times a to the y, you add the exponent, x plus y. So we can transition this into logarithm. So if we were to have a log to a base of a, xy, so it's a product, right? You can expand it with the same base. So log a to the x plus log a to the y. Okay? So it's the same idea. You can add it, but separate it with the same base. So for quotient law, we understand that if you were to have a same base, x divided by a to the y, you are going to subtract with the same base, x minus y. Same idea, you have log x divided by y. You could separate it like this. Next, we have a power law for exponential. A to the x to power of y. So when they are right beside each other, the exponents, you multiply them, x, y. It's same idea. So if we were to have log a to the x to y, we can bring this y, the exponent, to in front of log. So it becomes y times log ax. Now, keep in mind there's some restriction. X has to be greater than 0. And y also has to be greater than 0. And a, the base, also has to be greater than 0. But keep in mind that a cannot be 1, or else it's going to be linear and no exponential will work. Let's do a quick review. So again, power law, you let the exponent come in front of the logarithm when you have exponent within log. The product law, when it's multiplying, you can separate it by adding. For quotient law, if it's division, you separate by dividing. But keep in mind, all of this has to have the same base. You could also change the base law. So I could separate log x over log a. And now the b is usually the base of 10, but it could be any base. Okay, as long as the base is consistent. But usually we set the base to be 10. Then change of base for exponential. So if I were to have logarithm in the exponent with the same base, then I could bring x to the exponent again, right? So it would look like b log base a to the x. And then when you have same base, you could replace it. It becomes 1, so it's a to the x. Okay, so let's try some simplifying question and then evaluate. Simplify means you want to collect the like terms and do all the mathematical operations, and evaluate means your final answer should be a number. So first we have addition with the same base. So then we can put it together using a product law. So log 4, 8 times 32. So it's log to the base of 4 to 56. So then we know that, think of it this way, there's imaginary x. So it's 4 to the base of 4 to the power of x is equal to 256. And we know that 256 is 4 to the 4 equals 4x. So therefore x is equal to 4. Okay. Next, we have same base and subtraction. So that means it's log to the base of 4, 80 divided by 5, which is log to the 4, 16. Same thing. So you want to ask, 4 to an exponent of something should give me 16. Or what you could do is you could let this equals x. 4 to the x is equal to 16. We know that 4x is equal to 4 squared. So therefore, x is equal to 2. So notice that they are same base, which is great. We can apply the logarithmic law. And we have addition and subtraction. So log to the base of 5. So it's going to be 15 times 20, but divided by 12. So when we simplify, it's going to be 25. And this, again, 5 to exponent of something should give me 25. It's going to be 2. So you can write it 2 right away, or you could say 5 to the x is equal to 25, assuming that this is x. X is equal to 2. Next, so we don't have any operation, and we have to evaluate it. So therefore, this is assuming that this is x. So 16 to the power of x is equal to 4. But there's no way for 16 to go into 4. So let's make a same base. So 16 could be converted into 4 squared. So this is 16. X is equal to 4. So that means it's going to be, so the same base, so we equate the exponents. So 2x is equal to, there's invisible 1 here. So therefore, x is equal to 1 over 2. Example 2. So given log, we're given this expression, and we have to rewrite in terms of log bx. Okay, so let's see. Log b. So we don't like radicals. So I'm going to replace the radicals as exponent. So the radical, this is square root 2. So it's going to be 1 over 2. And therefore, and then I could do the power, right? Distribute to each exponent. So log base, so x becomes x, z half over y 3 over 2. Okay. And then equals, so I could separate it. So let's separate. So log to the base x, because it's multiplying, plus log to the base z, 1 over 2. And then it's dividing, so minus log the base y 3 over 2. And then I'm going to carry this exponent of the logarithm to the front, right? So let's bring this to the front and this to the front. So it's going to be log base of x plus 1 over 2 log bz minus 3 over 2 log by. Now we are rewriting in terms of log b to the x. So therefore, assuming that this is an equation equals 0, so I will be moving the last two terms to the other side. So log bx equals, so this is moving to the left side, so it's negative 1 over 2 log bz, and this is also moving to the left side, positive 3 over 2 log to the base y. And this is my final statement in terms of log base to the bx. Okay, so this time express as a single log, and then we're going to solve for x. So when we're solving for x, you want to make sure that check that it's the same base, and you want to equate it. So let's see. So we are given a same base here. The base in this case is invisible 10. And because it's adding, I'm going to collect the using logarithmic log. So log x is equal to, so first I'm going to move this to the exponent. Okay, so it's going to be log 4 squared plus log 3 cubed. So it's going to be log 16 plus log 27. And then I could use the logarithmic law, put it together now. Log 16 times 27. So it's log 432 and log x. So we can equate it because we have logarithm of a base 10. It's same thing. So therefore x is equal to 432. And we solved it because x is equal to 432. Next, okay, so same thing. Notice that it's the same base. Very good. And I'm going to bring it to the exponent by simplifying. So log 7x is equal to log 725 squared minus log 7 5 cubic. So log 7, 25 squared is 625 minus log 7, 5 cubic is 125. So therefore, I'm going to use the logarithmic law, log 7, 625, because it's minus, I'm going to divide it, 125. So log 7 is, this is equal to 5. Okay, so let's see if I could equate it. So we were given same base, so yeah. So it looks like x must be equal to 5 because it's the same base of log to the 7. And that is my final answer. Okay, so now this time it says use technology to evaluate. The reason why they're saying that is because, so for example, if I were to evaluate this, let's say x, so we could separate it using a same base, log to the 3 over log to the 2. But unfortunately, you cannot use any simplification using log law. You can't simplify it, so therefore I would use a calculator. If you could change the base on a calculator, you can do it right away. But if not, so you're going to press log 3 divided by log 2. And you will get 1.585. And we just evaluated. Same thing. So we are going to separate using a same base of log 10. So log 5 fifth root of 2 over log square root of 3. So there's not much you can do here. All you can do is you could punch it in, log to the 5th root. So if you don't know how to do the 5th root, you could press 5, and then you will see X, this button. Okay, so in order to use this button, you will have to press Shift to see the Shift. And this button is right above this sign. Okay, so you could press 5, Shift, and the upside down triangle. So log 5 shift square root 2 divided by log square root 3, and you will get 0.252. So sometimes when you're evaluating, you will get a decimal. It all depends on the question of how much further you can simplify using logarithmic law.